Hello everyone. I would like to start using the abacus with my students to show them how to square numbers, and then after squaring them also taking the sum of them. This is to help us get ready for solving our Pythagorean theorem problems. So I'm actually going to start off with a trick that's not in the Julius book. It's how to square any two-digit number starting in 1, so in other words 10 up to 19, and it's a trick that can be used on paper but also on the abacus, and it really speeds up the process of squaring these two-digit numbers, which can be time-consuming. So I'll show you the trick on paper, but then I'm going to show you how much faster it is to do it on the abacus. So if we take a look at this trick, the way it works is it's all based on the number that's in the ones digit. So to square 12, we bring the 12 down, and then we take a look at the number in the ones unit, which is 2, and we bring that down. And the first thing we're going to do is we're going to take the sum of them. So 12 plus 2, 14. Then we take that number that was in the ones and we carry it down. And this is the number that we're going to actually square. So 2 times 2, 4. However, any single-digit number needs to be written as a two-digit number, so we're going to need to place a 0 and the tens to hold that place. So then, once we write it as 0, 4, we can simply add down the columns, and we now know that we get 144 when we square 12. All right, here's another one. Let's take a look at 13 squared. So 13 squared, bring the 13 down. The number in the ones unit this time is 3, so we're going to add 3. 13 plus 3, 16. Now bring that unit, the ones unit down. That's the number we're going to actually square. 3 times 3, 9. Single digit though, so there's the 0 to hold the place value. Add down 169. Alright, so here's one more. 14 squared. There's your 14. Bring your ones digit down. First we add them, then the ones digit is what we square, so 4 times 4, 16. Add them down, 196. So I'll do one more with you, and then I'm going to show it to you on the abacus. So let's say we wanted to do 17 squared. Okay, so we bring down our 17, and the number in the ones digit is 7. So first we're going to add it, 24. Then whatever is in the ones is what you square. So 7 times 7, 49. And then you add them straight down. So 289 is what we get when we do 17 squared. And if we take a look at this 17 squared on the abacus, I'll show you why this trick is so useful. So grabbing the abacus, if I wanted to set up 17 squared on the abacus, doing it the traditional way, we have 17 on the top times 17 on the bottom. All right, so every time I move over a red bead, I'm representing my groups of 17, so there's my first 17, here would be my second 17, so I'd have to do 10, and then 7 more across the bottom, 3, I don't have enough, so then I slide over my 10, and this is very time consuming. So using the trick really speeds up this process. So the first thing you need to do though is do a little T of R and ask your students, well, what's 10 squared? Your students know that as soon as they get to 10 squared, they've hit 100. So anything past 10 squared is going to be something in the hundreds. So when we do this, we want to set up our beads on the hundreds rack. So I'm going to actually set up my 17 here. So there's 10 and my 7. Okay, so now using the rule, the first thing is you're supposed to take the 17 and add 7, because 7's in the ones digit. So there's 3, 4 more, I've added 7. Now you're supposed to take that 7 and square it and add it on, so 49. So here we go, 49. And there it is, 289. So this is definitely faster than having to move all the beads across to do 17 times 17. Now, I would teach this trick because I would like to have my students practice squaring numbers on the abacus and also adding them, taking the sum, because we'll be getting ready to do the Pythagorean theorem soon, where they'll have to do an a squared plus a b squared. So let's just take a look at a problem like this. Let's say they had to do 15 squared plus 23 squared. So for the first number, we could go ahead and rely on the trick. Bring the 15 down, 5's in the ones, so we're going to add 5 to it. Then bring our 5 down, square it. There's our 25, add straight down. We know we're going to get 225. So we could start off doing this on the abacus. then we'll have to go ahead and do this, our traditional method on the abacus. But then I'll show you how it's really easy to put them together on the abacus. So 15 squared. To do 15 squared, I would set up the 15, and then using the rule, or the trick that I just showed, we would first add 5. Oops, there we go, 5, and then 5 squared is 25, so 25. And there we go, we have 225, and I'm going to leave that down there. This represents our 15 squared. Now I'm going to do the same thing and square my 23, so here we go, 23 across the top. I'm going to skip a bar so I have room here, and then I have 23 across the bottom. So I'm going to do 23 times 23. Alright, so to do the traditional method, I slide over the first bead, and this represents my first 23, which is already there. Slide over my next ones, so that's another 23, so 23. Slide over my next ones, 23. Now I'm going to move up a rung, so I need to move up a rung here, 23. Move over, 20. Now I'm out, so I need 2 more. And there we are. So if we read that, we end up with 529. That's the square of 23. Now I would show them how they can add them on here, because for the Pythagorean theorem, they're going to have to be able to do an a squared plus a b squared. And as you can see, everything's nice and color-coded. We have our 1s in yellow, we have our 10s in green, and we have our 100s in tan. So starting with the 1s, I've got 9 up here, so I'm going to transfer them down here. I'm going to take 5 plus 9. So I'm going to move them over, and I'm going to do my plus 9 across the bottom. So there's 5 and 4 more. For my green, I need to move over 20, so I'm going to slide these over. There's 20. And then for my tans, I need to add 500 to 200, so slide that over, and there's my 500. So I end up with 754, and that's what we get when we take 15 squared and add it to 23 squared. So this process on the abacus is something I would like to work with my students to help them better understand the steps when they're going to be solving the Pythagorean theorem.